Okay, so section 2 of this chapter about lipids talks about acids, which are really our building blocks for a large majority of our lipids that are naturally seen. So, uh, fatty acids are these long unbranched chain that have a carboxylic acid at one end. So this is what they look like. They almost always have an even number of carbons. So typically between 12 and 20 carbons is the most common or most natural numbers of these fatty acid chains that you'll see. And a huge, I guess, characteristic of these fatty acids is they have two ends to them. So here, the carboxylic acid we call the hydrophilic end. And then the rest over here, let's do a different color. Our long chain is hydrophobic. So what do these even mean? So let's go to hydrophilic first. So we know that hydro means water. Philic is a Greek root for loves. So this means that the hydrophilic end loves water. It loves to be around water. It is dissolved by water. So like things attract like things, opposite of our relationships, I guess. And at least in chemistry, like things attract. And so because water has those oxygens and hydrogens, and carboxylic acid has those oxygens, they like being around each other. So these carboxylic acid ends really love water. They're hydrophilic. On the opposite end of the spectrum, we have the same hydro root, so water. And then this root, you guys are probably a little bit more familiar with, phobic. That means fears. So in this particular case, I'm going to write hates or fears. It's kind of personification of a chemical to fear something, right? But or to hate something, or really to love something. Well, we're just getting on a tangent here, but the carbon chain end hates water. So it tries to get away from as much water as possible and be like other things that it's like. So these long chains are going to hang out with the other long chains, and the carboxylic acids want to hang out with water. So we have two very distinct portions of these kinds of molecules. Okay, so there's a couple ways that we're going to represent fatty acids, particularly because they are very long. So all of these fatty acids here are all lauric acid. Which is the name of the fatty acid with 12 carbons to it. So you can draw these as their skeletal structures. So all of our organic content before we got too much into biochem, we always did these skeletal structures. So that's pretty common for organic chemists. It just kind of takes a while to draw out sometimes. We can also write the condensed structural formula. So this one's pretty long. I don't want to write it like this. I probably never personally will write it like this, but you can take that condensed structural formula. I sound like my mom. And you can abbreviate that down. So we'll just call this the abbreviated formula. So this is pretty much the most common way that you'll see it in the textbook, in a lot of notes and everything. You'll just see CH2, which corresponds to one of these carbons up here with two hydrogens on it. You'll just see CH2 in parentheses with 10. So that means there's 10 CH2 units. And it also makes it really easy to count how many carbons you have, because then we have 10 in the middle and then 1 on each end, so 12 total. Okay, so real quick, we'll talk about classifying fatty acids as well. So the first class of fatty acids are saturated fatty acids, which contain only carbon-carbon single bonds. So we've talked about saturated hydrocarbons before. So this is very similar. We're just going to have a carboxylic acid at the end. So overall, their properties are fairly similar to alkanes, especially those hydrophobic ends. So we have all of these names here: lauric acid, mystric acid, palmitic acid, and stearic acid. And these are those common fatty acids that are dropping my pen. Common fatty acids that are saturated. So they're only carbon-carbon single bonds in that long chain. So another way that this gets represented is this column here. This first number is the number of carbons, and the second number is how many double bonds there are. So this is saying that we have 12 carbons and 0 of them are double bonds. I didn't realize you guys couldn't see that. Okay. Here we go. You'll also notice their melting points. So lauric acid, for example, is a lot of what's in, or is a component in, like coconut oil. Pretty low melting point. That's why coconut oil sometimes is a liquid, sometimes is a solid at room temperature. Okay, continuing on, we have unsaturated fatty acids. There are 2 different types, but these are fatty acids that contain 1 or more carbon-carbon double bond. So these can have cis or trans isomers. However, the most often, at least naturally occurring, are the cis isomers. And you'll see, we'll talk later about how we get to the trans isomers. So we have mono-unsaturated fatty acids, which have 1 carbon-carbon double bond. Because there's mono meaning 1. So when we're looking at this, things like palmitic oil and oleic oil are mono-unsaturated fatty acids. They have a single carbon-carbon double bond in them somewhere. You'll notice, I wrote it up here, but forgot to talk about it, that when you have these cis double bonds, you kind of create a bend in your chain. So we draw it a little bit funky. We don't keep our bond angles completely correct in this, and we draw this funky little double bond in like a straight line, but in reality, it really bends and kind of creates like a kind of like a 120-degree angle instead of keeping it 180. So continuing on, we also have polyunsaturated fatty acids, which have at least 2 carbon-carbon double bonds. And so these will highlight those double bonds just to show we have 2 here, we have 3 here, through 4 down here. So there's a lot of different varieties of these because you can get the double bonds in different places as you go. But you can see where you can find some of these in soybeans, sunflower, corn, meat, eggs, and fish. So one thing to talk about with polyunsaturated fats is something that you guys, especially those exercise science and people who are interested in nutrition, this is what we're talking about when we talk about omega oils. So omega fatty acids. So when we use, so omega is kind of like a curvy W. I'm not very good at drawing it, so I apologize, but the curvy W means omega. And you've heard of like omega-3 or omega-6 fatty acids. They're things like, that's why they say you should have fish oil, is because they have your omega-6 fatty acids and all this stuff. So why do we even, what's the big deal? So omega fatty acids are polyunsaturated fatty acids that we cannot produce ourselves. Our bodies can only produce monounsaturated fats. So polyunsaturated fats need to be obtained in our diet, and that's why they're called essential fatty acids. So, or essential fats, is we have to have these in our body. Our body uses them but can't produce them, so we must get them from our diet. So when you're talking about these omega fatty acids, where that number comes from is we start numbering at the end. So by the end, I mean the end opposite of the carboxylic acid. So let's pick a more bright color. I'm going to zoom in a little bit too. So on this first example, I'm going to start numbering on this end. 1, 2, 3, 4, 5, 6. So this is an omega-6 fatty acid. And then down here we have 1, 2, 3. So this would be an omega-3. Omega-3 fatty acids are supposedly the really healthy ones. Why exactly, I did not read into, but yeah, so you can see all of these different fatty acids. We can determine what kind of omega fatty acid a polyunsaturated fatty acid is. And you will notice that oftentimes you'll see the polyunsaturated, the unsaturation will be right next to each other, kind of with one carbon or one CH2 in between. They'll be almost always just back to back like that. And so these are even more bent also. So instead of just having one little kink, they have lots of kinks and kind of curve around. Okay, so that's where we're stopping with our first little chunk on fatty acids.